Hello everybody. In this video I will explain the procedure to provide the prerequisite files for running the CapeTS module. CapeTS or CapeTS transient stability allows to provide a link between the Cape and the transient stability software such as PSSE. As you installed Cape on your computer, you can access to the uh, documents and help folder. You can find this uh, handbook about the Cape TS links, which explain the procedure step by step and the way that you can provide the database for the Cape TS. To run the Cape TS software, you should provide two different type files. The first one is the GDB file, which is the database of the Cape software. So to provide this file from PSSE, you should use some prepared files in the PSSE formats. The first one is the raw file formats in PSSE as the extension of .raw. The second one is the sequence data format, which is .seq, and to and use the Cape starter database, which is available in the root folder of the Cape in this under link. And the last one is the target GDB. To provide the database, Cape has the external program which you can find in the progs folder in the Cape root. So by opening this program, you will see this window that you should provide 4 different files to it. So in the raw data file, you should select your raw data from the PSSE. So I prepared this one for this simulation. I open this raw file. Then you should provide the sequence data. So I open the sequence data of my network, which has the 0 and negative sequence impedances of the system. The third one is the Cape starter database, which you can find in the Cape folder. It has some different type of the CT, VT, and different protection devices and relays. This is the default data of the protection in the database of the Cape. And the last one is the target database, which is all these data copied in these two file, and you will use it as the database in your simulation. So I wanna provide a name for that. you can choose the PSSC version that you use to build these raw data and the length of the lines and system hertz. And after that you can run the program. In the log file it will show that how many buses you have. I have 5 buses, 1 loads, 2 generators, and 4 lines and 1 transformer. All the data that is converted to the CAPE database will be shown here, and at the end of this log file it said that data transfer completed. Now you have the database for your simulation in the CAPE. The next step is to map the branches and buses of your network from PSC to CAPE. For this purpose, there is a program in the CAPE folder as the name of network mapper.exe that you can find in the progs folder of the CAPE. 2 different files with the GDB extension are used as the input for this program. One is used as the source file and the other one is the target database. The source file is the one that you generate by the PSSC to database program from previous step. I will open my simulation folder. Now you can see that I built the single machine InfiniBus as I named it GDB. So you should copy this file and put it in the same folder. I name it as one is for protection platform, and the other one is for planning, or which is used in PSSC link. Now I will open the network mapper. So you should provide one GDP as the source database. I use the planning one, and the other one as the protection as the target. You can find this procedure in this manual as explained here at page 17 and 18, which option you should choose and in your simulation. Then I will go to the next tab, which is used for bus mapping. So source file, internal target bus is internal. So I will push the auto generate bus map, which is automatically map the buses between these two database. So it's better for the huge network, it's better to use the auto generate bus map and then add the other buses that is not connected to the protection database by manually. As you can see that I have 5 different buses, and in the source and target database they have the same number, the same name, and the same kilovolts. And I can save this file with the extension of BME, bus mapping. And on the third step I will map the branches. So I will do it first by pushing the enhance branch map. You can see the details of this procedure in this handbook. Now you can see that I have different lines from to, and in the target file it's from to and the same name and the same data. If the software cannot detect the branches and pair it together, you can see different branches here and you can add them and pair them by manually. Right now there isn't any problem, and I will save this file, and it has the extension BRM. You can see the log file of this procedure, so you can see all the data and the converted and transfer data from PSC to K.